Hi! Welcome back to our example where we have been able to configure our FPGA with a given design. Even if you are not familiar with it, well, this is not a big issue. The basic idea is that we went through the entire design process and we have been able to create the proper configuration bitstream. This is great. We have a working FPGA and this is what we are here for. But wait. What? Wait a second. Something is happening. While we were executing our design, we just realized that something has to be changed. It's not a big thing. We just have to modify the configuration of one CLB. Not a big thing? Are you sure? Well, you're right, it's not a big thing. It's huge, gigantic. We don't know how to do it. This means that even if the updated is small, even if it's not involving the other elements, we do have to start from scratch the entire design process. Wow, that seems to be insane. It's okay with us. We're just using a super simple FPGA. But what if we are going to work with a real one? Well, this can be huge. And this is exactly the rationale behind the partial reconfiguration. We do need to work towards the creation of a reconfigurable friendly ecosystem. Reconfigurable systems are gathering an increasing interest from both the scientific and the industrial world. The need of a comprehensive framework which can guide designers through the whole implementation process is becoming stronger. It's quite hard to have just in one framework support to define which IP core has to become a reconfigurable core, perform the actual swap of reconfigurable cores and the FPGA reconfiguration, define interconnection among reconfigurable cores, identify from an higher level of RTL level specification how to define the reconfigurable cores. And these are just few examples. I can provide you more. Because of this scenario, we can find many examples of tools, initiatives to try to cope with it. One of the earliest examples in trying to provide a tool to design partial configuration bitstream has been done by Xilinx. They've been working on a design flow for partially reconfigurable architecture, which was characterized by a set of subsequent phases to implement the architecture where partially reconfigurable requirements were explicitly exposed. In having a look to the history of Xilinx efforts in providing tools to support partial reconfiguration, we can identify three official design flows: difference-based, also known as small bit manipulation; module-based, PR, that was the shortened version of partial reconfiguration. And nowadays PR is fully integrated into Xilinx tool flows. Xilinx has been always interested in innovating and in trying to provide to the designers tools capable to answer to their needs. Over the last 2 decades, they've been able to reinvent their tools quite well. They started with the ISC and was basically a framework to create configuration bitstream starting from VHDL Verilog description. Xilinx realized that designers were looking for something more, something different. They saw an opportunity in opening the FPGA world to people not fully trained in VHDL and Verilog, and this is when EDK and SDK arrived on the market. These tools were providing building blocks to the designer to allow him or her to assemble them to create a working system. One of the interesting parts was that if you were able to design your own IP in VHDL Verilog, you were still having the opportunity of integrating it into a design that was created in a much easier way. This means that even if you were a skilled IP designer, you were gaining in productivity because Xilinx was providing you a tool to design the overall system, where to add your IP without having to worry of the entire system design by yourself. The next big step was the introduction of the support to the high-level synthesis. And this was done with Vivado HLS. But this was not enough. Xilinx was looking for more. They were looking for tools to allow both an embedded system designer and an HPC one to have the same design experience, or at least to gain the same benefits in terms of productivity. And this is where we are now, with SDSoC and SDXL. Obviously, there are other tools. I just name a few examples to give you an idea on how things have changed. And companies were not the only one in following this race.